All right, so now implicit differentiation is different than anything we've done before because for the first time we are taking derivatives of y. We haven't really done that before. We've always had an equation where y was all by itself and we just said y prime. That's all we ever did. Now we're going to have problems where y is in the middle of the equation and we're actually going to do the derivative of y, okay? So I'm going to start with number 1. Somebody tell me what's the derivative of 4? 0. So I have 0 equals, what's the derivative of 5x squared? 10x. Okay. What's the derivative of 2y to the third? 6y squared. Okay. Now, in most equations, y would not show up in the middle of the problem. It would be isolated in the beginning of the problem. So what implicit differentiation says is y should have been isolated in the beginning, so I don't know what y is representing. So what I have to do now is I have to say this was the derivative of the outside. The derivative of the inside is just the derivative of y, which is dy dx. So implicit differentiation says I always look at that and go, oh, I don't know what y represented, so I'm going to write the derivative of the inside, which is dy dx, okay? This is the part that takes some time to understand. Have you done all the notes? Do your notes. Do your notes. Do your notes. Elena, will you close the door? All right, so the part that you need to remember, whether or not you're understanding all the steps and all the why about it, like understanding it, what you always need to do is anytime you're doing a problem where you took the derivative and you have a y in there, you just tack a dy dx on the end. Okay, so we might not understand it today. It might take a little while of doing it before we finally understand what that actually means. But for today, your takeaway message is whenever I do a derivative of y, I stick a dy dx on the end. Can we do that part? Okay. Now, your goal from here is to solve for dy dx, to get the dy dx alone. Oh, you can turn that one off. Sorry. You like it? I mean, is it reflecting off the screen though for anybody? We're good? We're good? Okay. All right, so how would I get the dy dx alone? Okay, so we'll minus 10x and minus 10x. And then what should I do? So we have dy dx. Is there anything about that can be simplified? Yeah, so we can divide by 2 on the top and 2 on the bottom. And we are done. That's it. Yeah, they're not, if you keep in mind, all it really means is that every time I do a derivative of y, I stick a dy dx on the end and get it by itself. Kind of, yeah, you can think of it that way. Okay, let's do number 2. Okay, so start with the first part. What do we do with the first part? 3x squared. Okay, now the second part is a product rule. Do you see that? That's an x squared times a y. That's a product rule, okay? So we're going to say plus. Now we're going to do first times the derivative of the second. So x squared times the derivative of the second, and the derivative of y is 1, and what do we tack on the end? dy dx. So that was first times the derivative of the second, plus the second times the derivative of the first, 2x. Okay, so that was us doing the middle part. We do not do a dy dx because we didn't do a derivative of y. Okay, so first times the derivative of the second plus the second times the derivative of the first plus, okay, what do we get for this part? 8y dy dx, okay, equals 0. Now, I will say you got to watch out for the derivative of a plain number because for whatever reason, when I am doing these problems, I always forget that that derivative is 0. I almost always make it equal 6 or whatever. So watch out for that at equals 0. Okay, so what our goal is next is we clean it up a little bit because it's easier to deal with, and then we're trying to get the dy dx to one side. Okay, so x squared times 1 is just x squared dy dx. If I have y times 2x, how would most people write that? 2xy. Okay. So I have two terms with a dy dx, and I have two terms without a dy dx. Yes. Okay, so we're going to move both of those over. So I have an x squared dy dx, and I have an 8y dy dx. And then on the other side, I have a negative 3x squared and a negative 2xy. So we want to get the dy dx to be something that's completely like by itself, right? And so what Stephen was saying is if you factor out the dy dx, you have x squared plus 8y dy dx. Then when I factor out the dy dx, it's kind of like the dy dx is able to get alone now. Since it's factored it out. We had two of them, now we made it so there's only one of them because we factored it out. And then you can divide that parenthesis over to the other side. So dy dx is negative 3x squared minus 2xy divided by x squared plus 8y. You cannot simplify that. You could factor a negative out on the top, you could factor an x on the top. But if you did that, it would not cancel with anything on the bottom, so it would just be like doing extra work. Yeah, yeah. Unless you wanted to kill a puppy. Let the records show that Dugan said, oh heck yeah, when I mentioned killing puppies. And yeah, but Toby's all drugged up. Or yeah, he's
you should have seen me.
He's mildly drugged up. All right. How should you rewrite number 3? There we go. Okay. What should you keep in mind when you do number 4? Product rule plus another product rule. And you have a derivative on the other side. But that's not a product rule because it's a coefficient. So coefficients are kind of nice. Okay, product rule, product rule. Yeah, you can. Yeah, something will cancel out, yeah. Would we like to do number 5 because it has a trig function? Yes? Okay. So when we look at the first part, what do we see? Product rule. Okay, so we're going to do first times derivative of the second, so 2y dy dx, plus the second times the derivative of the first, which was 2x, okay? So that was us doing the derivative of the first part. So first times the derivative of the second, plus the second times the derivative of the first, plus, okay, what do we see here? Product rule again, because we have x times sine y. So first times the derivative of the second, cos y, what do I put after cos y? dy dx, plus the second times the derivative of the first equals 0. My apologies for leaving you more than enough space.
Oh, yes.
Sorry.
Where'd Wolf go?
All right, so let's clean it up a little bit. So what should we write for this first term?
2x squared y. Yeah.
Okay, 2x squared y dy dx. Okay, plus 2xy squared plus, yeah, just take the dot out, x cos y dy dx plus sine y equals 0. Doesn't that look like cozy? All right.
It does so
Yeah. So, yeah, cosy, I guess. So what do we do now? Yeah, so we're going to take the stuff without the dy dx, and we're going to move it over to the other side. So I'm going to keep the 2x squared y dy dx, and I'm going to keep the x cozy dy dx, and then I've got negative 2xy squared negative sine y. Okay. Now what do I do? Factor out the dy dx. Do you guys care if I put the dy dx at the beginning or the end? You like the beginning better? Okay.
Well, I said it first, so.
Well, I mean, if you're factoring something out, let's do it.
Okay. So we took it, we moved it to the front. What do we do now? Yeah, take those parentheses, move them over. Done. Whew. Okay. Let's just make sure. I think the other ones are okay. Yeah. Yeah, okay. So go ahead and yeah. So we're gonna go ahead and work on this. The answer key is on the wall, the board. I'm going to hand back the tests, and you are gonna hide your test from Desi and Toby so they can't see it, okay? Don't. So Toby's blind and a little bit drugged up and somewhat emotional. So keep your test away from him. And
yeah, probably a little.
all right.